All right, so we're going to do a discussion on solutions this morning. All right, when we're talking about a solution, we tend to be talking about a well-mixed mixture, usually with water, although there are lots of kinds of solutions. The stuff that dissolves in a solution is called a solute. The stuff that does the dissolving is called the solvent. All right, so Kool-Aid, your sugar and your flavoring is the solute, the water's the solvent. The more solute you dissolve, the more concentrated a solution gets. All right, if you've ever had the orange juice that comes in the can from the freezer, that is frozen orange juice concentrate. You then take it out, dump it into a pitcher, you add several things of water, and we say that we have diluted the solution. A dilution is when you add more solute. All right, the unit of concentration we will use is molarity, and it is a measure of moles of solute over liters of solution. Now, get your mole maps out. I'm actually going to do this. If you get your mole map out for a moment, we're going to add another piece to our mole map. Because, as you can see, moles per liter, we know moles here. If you know the volume of something, you can calculate molarity by dividing by volume. Now, if we switch that around and we know the volume of a liquid in liters, we can take the volume and we can multiply it by molarity. How does that work? Well, volume is measured in liters, and molarity is moles per liters. If we multiply those, the liters will cancel, and we get moles. By the same token, if we divide by molarity, if you have moles and you divide by molarity, so we put moles on the bottom, liters on top, moles will cancel and we'll get a volume. All right, so add that in to your mole map. And I'm going to bring up a different picture that has it already in there. And we'll set that here. The only thing not on this picture was moles divided by volume gives you molarity. All right, so our first question asks, what's the concentration of a solution where you start with 0.20 grams of copper 2 nitrate? Right? So we're going to start with grams. If we look at our mole map, if I can get the pen to work, if we're starting with grams, no, the pen's not working yet. Starting with grams, and we want to go to moles, we follow this arrow and we divide by the molar mass. The molar mass of copper 2 nitrate happens to be 187.56. That is going to give us moles. And if I do the math, I get 0.001066. I'm going to put lots of values in there because you'll see in a moment. We're not worried about sig digs yet. All right, that's our number of moles. How do we calculate molarity? We take moles divided by volume. We're given volume in milliliters. If we move our decimal 3 points to the left, we have liters. Divide by 0.4. And our final molarity is 0.002666. And we need two significant digits, so we'll drop those and we'll round to 0.0027 molarity. Now the second part asks about the concentration of each ion. To do that, we're going to take our molarity and we are going to look how many sodium or coppers are in one copper 2 nitrate molecule or formula unit. And the answer is 1. So this is moles per liter, remember. There is 1 copper atom or ion in each formula unit of a copper 2 nitrate. So we just multiply by 1 and we get 0.0027 molarity of copper ions. For the nitrate ions, 0.0027 moles over liters. And now we're looking at 2 nitrate ions for every 1 mole of copper 2 nitrate. And so we would end up with 0.0054 molarity of nitrate ions. All right, the next one's asking for grams. So we go up here, we're going to solve for grams. And we're given volume and molarity. If we follow the arrow from volume to moles, we have to multiply. So we're going to take 0.015 moles over liters of permanganate, and we're going to multiply that by our volume. Again, we have to divide by 1,000, so we get 0.250 liters. And we come up with 0.00375 moles of potassium permanganate. What are we solving for? We're solving for grams. How do we go from moles to grams? Multiply by the molar mass. Molar mass of potassium permanganate is 158.03. Just realized the microphone was not stuck to my shirt. Multiply 0.00375 times 158.03. You get 0.5926 grams. We need, there's only 2 sig digs there, there's only 2 sig digs there, so we'll round that to 0.59 grams. Our third, we say what volume in milliliters, so we're going to solve for volume this time. So we're solving, if we look at our map, we're going to solve for volume this time. The question says, that tells us molarity, and it tells us grams. So we're going to start with grams, we're going to go from grams to moles, and then moles to volume using the molarity. We have 15 grams of NaOH. The molar mass of NaOH is 44 grams in 1 mole. That will give us a number of moles. 0.34091 moles. Now we want to go from moles to volume, and it shows dividing molarity. So we'll take 0.34091 moles and divide that by the molarity, which is 0.350 moles in 1 liter, and that gets us a molarity of 0.9740. We have 3 sig digs here, 3 sig digs here, so we can say 0.974 molarity. One last thing with solutions. On occasion, we'll have a need to make our own solution. Now, we tend to buy concentrated solutions. For instance, this first picture is a picture of concentrated hydrochloric acid. It has the blue lid, that's the clue. Hydrochloric acid has a molarity of 12 when it's concentrated. Nitric acid uses the red lid. They have a concentration of 16 molar. And sulfuric acid has a yellow lid, and it's the most concentrated at 18 molar. Okay, we call these stock solutions. Stock solutions are simply concentrated solutions that we dilute. In the way we dilute, or the way we calculate what we need, we use the molarity of one solution times its volume, and we set that equal to the molarity of the second solution times its volume. For instance, a stock solution of 1 molar sodium chloride is available. So this is our molar 1. How many milliliters are needed? So how many milliliters of sodium chloride? We're going to call this volume 1. This is our volume 2, and this is our molarity 2. So we just set up a little algebra problem. Molar times volume 1 equals 0.1000 liters times 0.750 molar. How do we solve for V? Divide both sides by 1. That will cancel our molarity out, and we'll have an answer in liters. Second one, we need to make 2.5 liters. That's going to be our volume 1. This is our molarity 1. How many milliliters of concentrated hydrochloric acid? This is going to be our molarity 2. We're solving for volume 2, and we can use hydrochloric acid as 12 molarity. So 2.50 liters times 3.0 molarity is equal to our volume times 12. Divide both sides by 12. Our molarities cancel out, and we'll have an answer in liters. Now, you'll notice the question asked for milliliters, so you'll want to multiply by 1,000 to change it. Okay? So that is how we do this. Now, let's see. If you look at molarity worksheet number 1, we have on number 5 one of those type of problems. Number 5, a bottle of 12 molar, so that's going to be M1. It has only 35.7 milliliters in it. That's volume 1. What will the concentration be? That's M2 and volume 2. So 12.0 molar times 0.0357 liters is equal to our second molarity times 0.250 liters. Divide both sides by 0.250 liters, and we'll get our molarity. All right, thank you very much.